Hey everybody, so this is your intro video for our very last lab besides our projects that we're going to be doing. And this is the Complex Circuits 2 lab, and again we're going to be using multisim. So I wanted to give you some background. Hopefully in class you're also covering this. All right, so let's take a look at an RC circuit. That's what we're going to build, and that is a capacitor and a resistor in a circuit. All right, so let's just look at a simple one. I'm going to have a battery, and then I'm going to have a resistor, resistance R, and then I'm going to have a capacitor, and I'm coming back around, it connects to the battery. Okay, that kind of looks like a ground, but sorry, it's a battery. Okay, so this is our voltage V. This is our capacitor C. Okay, so in this circuit, now let's imagine here, and I should probably put that in first, that we have a little switch. Okay, so we're not going to turn it on yet. So here's a little switch. When we close the switch, then the circuit starts going. Okay, now what is going to happen when we put the voltage on by closing the circuit is that the capacitor charge is going to build up on the capacitor so that will be a certain voltage across the capacitor. So I'm going to put this over here. This voltmeter, think of this as a little voltmeter, so V of T, because as time goes on, the voltage will build up on the capacitor. Okay, so let's see what the equation is that tells us. Now, I'm not going to derive everything here. This is something hopefully you've seen in class, but our equation that tells us what the voltage across the capacitor is, right, is going to be, give me a second, I'm going to write it down here. I'm going to write it in a different color. Okay, so our voltage equation is this. So we're going to build up, so V of T is going to build up to V, this value, with this equation, 1 minus e to the minus t, so that's time, over r times c. Okay, so r times c is all in the denominator there, okay? So as time goes on, what happens is this, because it's a negative exponent to this e, will go to 0 as time goes to infinity, and you'll end up with just v, okay? So the voltage is going to build up, and I've got a little picture here that you can see, and unfortunately I drew on a little part of it here, but anyway, so here's the, if you look, we're going to build all the way up to the voltage, and this little tau down here is RC, so I can write this again as V 1 minus e to the minus t over tau, okay? And that's a little tau. I know it doesn't look like this tau, but it's very similar to this tau. Okay, so how about that? There we go. So after one value of tau, right? So one value of RC, this becomes, so we're going to go after one tau, okay, which is of course 1 RC, we get this. So the V of T is going to be V 1 minus e to the minus 1, right? Because it's tau over tau. And this gives me, as you can see over here, this will give me V times 0.632, which means that it's 63.2% of the final voltage. Okay, so that's after 1 tau. After 2 tau, right, you get up here to 86%, 86.5, 3 tau up to 95%, et cetera, et cetera. When you're up to 5 tau, you're up at 99.3%, right? So if you wait for 5 tau, okay, so let's calculate tau. So let's just have an example where our R, I'm gonna get my red again. So let's say we have R equal to 1 kilo ohm. And the capacitance, sorry, C, oh, that's so bad I have to redo it. And it's kind of pink, not red. All right. So C is equal to 1 microfarad. Okay. All right. So tau is R times C. Let's put my green back. R times C. So we have 1 times 10 to the 3 ohms times 1 times 10 to the minus 6 farad. And ohms times farad, the unit is seconds. You can prove that to yourself. Go look up these units up. Okay, and as you can see, we have 1 times 10 to the 3 and 1 times 10 to the minus 6. So I get 1 times 10 to the minus 3 seconds, which is the same as 1 millisecond. Okay, so if we're looking over here at this plot, if we were using this circuit, after we close the switch, we would have after 1 millisecond, okay, you would be at 63% of the voltage. After 2 milliseconds, right, we would be at 86.5%, et cetera, et cetera. Okay, so our goal in this lab is to use this fact to be able to calculate C. Okay, now we're going to use multisim, so of course we already are going to know what the capacitance of our capacitor is, but that's going to be our known value, and you're trying to measure it using a graph like this, right? And try to see if you can figure out, given that you know what you're going to pretend that you know the resistance, but you don't know the capacitance, okay? So if you can measure, right, if you could see like, okay, when does the voltage get to 63.2% of its final value, right? Then you can look down and see, oh, tau, in this case it's 1 milliseconds, but you could read off a graph what this is, right? When we have a graph that we see, and then you'll know RC is equal to 1 millisecond, and since you already know R, you're going to calculate what C is from that measurement. Again, you already know what C is because in multisim, you have to choose a C, right? Okay. But that is going to be our known value, and your measurement is going to be compared to that. Okay. All right. So let's take a look at a little simulation that's not a multisim simulation, but to give you an idea of kind of where. Okay, so here's our simulation. So what I want to show you is here's our RC circuit. So here's the capacitor, here's the resistor, and here's the battery. These little dots are supposed to be electrons. Okay, so these are different resistance and capacitance that we were using before, but we're not really going to measure anything. We're just going to watch the simulation. Now, when I turn it on, what's going to happen is that you're going to see the blue voltage start, and this is the voltage across the capacitor, start rising. Okay. And ignore this. This is the current, but we're going to ignore the red line. So we're not doing current in this lab. So let's see what happens. So let's play and notice that the voltage is rising. And notice, look at this, the current is going to 0, right? So we don't really care about the current, but I'm just noting that. And this is going to asymptote basically to 6. And we will just pause it there. And now it's just going to sit there, right? If you let it go forever, it's literally just going to sit there. We saw in our equation before that as time goes to infinity, the voltage goes to its maximum value and just sits there. Okay, now what happens if I take the battery out and reconnect the circuit? So I'm just going to remove the battery, reconnect the circuit. Well, what's going to happen is that the capacitor is going to act like a battery because it's fully charged up to a particular voltage, in this case 6 volts, and it's just going to start dumping current through the circuit, and it dissipate through the resistor, and the voltage will go down to 0 again. So let's do that. Let's remove the battery and notice that it's all hooked up together now. And let's play again. So what's going to happen? Look at the voltage. Voltage is going down to 0. Okay, and now it's all the way down to 0, and then we'll pause it. Okay, so let's do this now in succession. So what I'm going to do is I'm going to reset, and then whoops, I gotta pause it, and then I'm going to let it go, the voltage go up to the maximum, and then I'm going to take the battery out and let it go down, and then I'm going to turn it back, put the battery back in and let it go up to its maximum, and take the battery out and let it go down. because this is what we're going to see in our experiment. I'll explain that in a second. All right, so let's play. So let's let it go up to its value. Come on, you can do it. And then battery moved. And when it gets down to 0, roughly, I'm going to put it back in and charge it back up. Never mind that current thing. And it goes back up, getting up to 6 again. And remove the battery, and it discharges again. And one more time, put the battery in the circuit. Let it charge up. Okay. And then remove the battery. Okay. So I hope you can get a feel here for this, what this looks like, right? I'm charging it up, discharging it, charging it up, discharging it. And I'm doing that by literally taking the battery out and putting it back in. Well, that's annoying. You can imagine actually trying to do that. You could probably do that with a switch setup somehow, build this circuit and have a switch. But there's an easier way to do it. And when we actually do this lab in person, we use a signal generator, which is just a way of saying a voltage that alternates between on and off, and on and off at some frequency. And that's kind of like having the battery in the circuit and out of the circuit, and in the circuit and out of the circuit. Okay, so that's what we're going to do on multisim in the next part. Okay. 1 second and I'll get to multisim. Okay, so here we are at multisim. I've got a blank circuit here. All right, so remember I said we're going to get a voltage that is going to turn on and off and on and off. Okay, so to do that, we're going to come over here and we're going to go to our sources and we're going to go to what's called a clock voltage, which is really just a square wave. And I'm going to put that down. And then I want an RC circuit. So of course I always have to have a ground in multisim. That's just the way it works. And then I've got to have my resistor. And I'll put that here. And my capacitor here. I'm going to put that over this side. And then I got to wire everything up as usual, okay? So we're going to wire this up to here, wire this up to here, wire this down to here, and whoops, hello, there we go. And then we're going to wire here to here. Okay, we're good. We have our circuit. Now we need voltage probes. So I want one where I can look at just the square wave. So for that, I'm going to put a voltage probe right here, right where, right before anything happens, right before anything goes through, before the voltage is diminished by the resistor or the capacitor. So I'm going to put it right there. Then I'm going to put a second probe to measure the voltage across the capacitor. And so I'm going to put it here. Okay, so remember in multisim it's a little weird, but because the voltage is 0 by the time it gets over here, right? Because it's sort of been spent, right? So the 5 volts is kind of, can think of it as being spent. Then if you put your voltage here, it's barely going to measure the difference between the voltage across this capacitor and 0. So it's going to give you the voltage across the capacitor. Okay, so we want to graph this. So I use the split up here, and I'm going to also turn on my my settings for my grapher, and let's just graph. Okay, now it's going, as you can tell. It's just plotting. And if you look down here on the minimum and maximum voltage, you want it to be like 0 to like 5.5 because the maximum voltage here is 5 volts. So you may not have it set up that way. So make sure that when you turn it on, if you don't have a problem seeing it, you change this. I also have the trigger on none. I like it that way. It just seems easier to me to deal with. Okay. So I'm just going to stop it so I can just look at the graph with all this busyness going on. And let's look at what we see. Well, first of all, in green, because of this probe, we see the square wave. Just like I said, it goes on for a while, then it turns off. Then it goes on to 5 volts for a while, then it turns off for a while. then it goes on for a while, and then it turns off for a while. And if you notice right here, here's the beginning of one of them, right? It's going to turn on right here. That's at 20.054 seconds. And then it's going it's going to stay on, and then it's going to go off. And then again, it's going to turn on again 1 millisecond later, right? That's because the frequency here is 1 kilohertz. And the time that you're going to see between starting to go up on one cycle and starting to go up on the next cycle is 1 over the frequency. So 1 over 1,000, right, is 0.001 or 1 millisecond. Okay, so it's going on for half a millisecond, off for half a millisecond, on for half a millisecond, off for half a millisecond, over and over and over. All right, let's look at what the capacitor is doing. So if you notice here, right, this capacitor voltage, it's not starting at 0. It's climbing a little bit, and then the thing turns off on it, and then it's going, and it's dissipating a little, and then it turns back on, and then it's climbing a little, right? It's never getting to the 5 volts. It's never getting all the way down to 0 because this thing is turning on and off too fast for it, right? It's not giving the time it needs to get all the way up to 5 or to get all the way back down to 0. Okay, so you have to choose your frequency correctly so that you can measure the capacitance by measuring the time constant. So if we go back to our circuit here, you can see, what do we want? We want something that goes all the way up to the maximum voltage and then goes all the way back to 0 when the thing turns off. Then when it turns on, we want it to go all the way back to the maximum voltage and all the way back down, right? So we need time. We need enough time in the on phase and the off phase for that to happen. Okay, so you have to play with the frequency here, and the lab kind of guides you through that. All right, now when you get to the point where you have a nice graph, right, that kind of looks like this, then you know what you can do. You can go up and say, oh, I want to find out, where is it 62.3%, right? Where is it 63.2% of the maximum, which in this case is 5 volts, not 6 like this. And then at that point, you look down at the time, and that will be your time constant. That will be tau. That will be R times C. And remember, you're pretending you know R, but you're pretending you don't know C, so you can calculate C. Okay, but you do have to play with the voltage, with the frequency so that you give it enough time. So you have to play with that, all right? And here you can see you can change that frequency. You can type in here, 10 hertz, a billion hertz, whatever you want to do, right? I think you probably have an intuition that you should probably go down in frequency because this is not giving this capacitor enough time. And notice that my resistor and my capacitor are the same ones I used in the example, so the time constant should be a millisecond, right? Okay, so in a millisecond, it's supposed to get to about 63% of the high, but it's only turning on here for half a millisecond. It's not even giving it any time even to get 63% of the way, much less all the way up to 5. Okay, well, hopefully that's enough info to let you do the lab. All right, well, we'll see you next time. Email me if you have any issues, and we'll talk to you soon.